should not take us very long. So your quotient of powers property. Please write the following rule down. If you have the same base being divided, so it makes a quotient, you subtract the exponents, as opposed to if you have the same bases and you're multiplying, you add the exponents.
I want to have you.
You're not going to be able to handle that?
I wrote down 3 words.
All right.
I'll look at Zach, don't worry. Just write down each one.
So a to the m all over a to the n is equal to a to the m minus n. Let's add that up onto the board. So a to the m over a to the n is equal to a to the m minus n. So what would this example be? 2 to the 7th divided by 2 to the 2nd would be 2 to the 5th. It's going to unveil itself. I didn't want you guys to work ahead. Wait for it. Wait for it. Okay? Next one. X to the 4th over x to the 3rd would be x to the 1, which is just x. Okay, Nick, relax. Are y'all good? Please let me know if I'm moving too fast. C. Let's make it a little bit more complicated.
First got add, and then you
Write it down first, please, Colin.
Alright.
So you've got d to the 4th, e to the 3rd in the numerator, Marshall and Christian. Well, don't talk about math right now. Listen to this. Then we got a product of DE being squared. So before we want to do anything, let's simplify that denominator. So my numerator is going to stay d to the 4th, e to the 3rd. Distributing that power of 2 gets me d squared, e squared. Now look at your like bases. D to the 4th over d squared is d squared. Good. E to the 3rd divided by e squared would just be e. Good. Okay. Not too crazy yet. All right, next one. D. We've got 3 times 4 to the 3rd times 5 to the 5th all over 3 squared, 4 to the 4th, 5 to the 3rd. Now I'm going to show you 2 ways to do this. Let's start with the 3.
Let's go first. Hold on.
The exponent of the top 3 is what? 1. If you do 1 minus 2, you end up getting what? So I'm going to write out 3 to the negative 1. 3 minus 4 gets me 4 to the negative 1. 5 minus 3 gets us 5 to the 2nd. What's going to move to the denominator?
3 negative 1 and 4 negative.
So I'm left with 5 squared up top, 3 to the positive 1 times 4 to the positive 1.
So it'd be 12.
So what do I get? 12 in the denominator. What do I get in the numerator? 25. Now this is how I like to think about it. If I focus just on the 3 base right here, I have 1 3 up top, 2 3s in the denominator, right? If I were to cancel out a pairing of 3s, I'm left with 1 3 where? In the bottom. That's the way I usually think about it because I don't like going to the negative. I just like thinking about what's left over. If I do the same thing for the base of 4, if I have 4 3s in the numerator, 4 4s in the denominator, and I cancel out my pairs, I'm left with 1 4 in the denominator.
So it's like the 5 minus 3 is 5 squared. It goes on top if it's...
Because your highest exponent is up there, yeah. Because you'd have 5 5s, 3, cancel them out, you'd have 2 5s left over in the numerator. So usually look at where the highest exponent is. That's where it's going to end up being. Okay? Did you get there, Colin, before I got to the answer?
Uh-huh.
Good. All right, so now we're going to bring some scientific notation back into the mix. So now we've got the scientific number 3 times 10 to the 10th being divided by, so I'm going to put it over a fraction, 6 times 10 to the 6th power. So I guess I really need my parentheses there.
Is that a times or an x?
Well, it's times. Scientific notation uses the x for a times. All right. So let's look at what the bases are. Right now, what's the exponent on my 3? It's a 1. So really, this is the same thing as having 3 to the 1 times 10 to the 10th divided by, my exponent on my 6 is what? 1 times 10 to the 6th. Do I have the same bases occurring right here? No, because right now my base is 3 and my base is 6. Do not, some students will do this, 3 divided by 6 is not 3, because they subtracted 3 and 6. Don't subtract bases. What does 3 over 6 reduce to? 1/2. So let's right now write that as a decimal since we're in scientific notation. So 1/2 times, if I've got 10 tens in the top, 6 tens on the bottom, and they cancel them out, how many tens am I going to be left with? 4. So times, I'll use parentheses so we don't get confused with x's, 10 to the 4th.
Okay, wait, hold on.
5,000.
Don't you have to do it for the 3 and the 6? Don't you have to do exponents? Not.
They're not the same bases. It only works when you have the same base. 3 and 6 are not the same base. So am I moving my decimal to the right or to the left? To the right, how many spaces? 1, 2, 3, 4. So we get 5,000. We get there? Okay, next property we gotta cover. Hang in there, guys. So just like in multiplication where we had a product being taken to a power, instead of having a product being taken to a power, we can have a quotient being taken to a power. And just like the product, where you distribute the power to both the terms on the inside, the same thing applies to a quotient. So the positive power of a quotient property tells us that if I have a quotient A over B being taken to the nth power, it's going to be equal to A to the nth all over B to the nth. So I'm going to write that up here on the board with our list. So A over B to the nth is equal to A to the nth, B to the nth. Okay? So, what am I going to get here? If I have the quotient 4/17 squared. 4 squared over 7 squared. What is 4 squared? 16 over 49. You got this?
Yep.
Easy.
All right. Next one for this property. Let's make it a little bit harder.
Nah, man.
3D squared
Easy.
over EF is being taken to the 4th power. So now you got a product up top. So that means I need to take that 3 to the 4th power. Don't do 3 times 4. Do 3 to the 4th power. What's the exponent going to be on the D?
8.
8. Good. All over, what's the exponent going to be on E? 4. And then F to the 4. Do I have any like bases anywhere to subtract anything?
No.
Nope. So the only thing I would do here is take 3 to the 4th. What is 3 to the 4th? Is that 81? So then I would get 81, D to the 8th, E to the 4th, F to the 4th. Got it, Aiden?
Pretty much. I mean, how do you know? Oh.
All right, next one. 2x to the 3rd all over xy to the 3rd. And that whole thing's being squared.
When you add exponents, right? Or times something?
I don't know.
I don't either. That's why I asked.
So let's work in the numerator first. I'm going to take 2 and square it. My exponent on the x in the numerator is going to be x to the 6th power. Well, not quite. Got to go further. Down here, let's work this first. Right there. X to the 3rd, y to the 3rd, right? Now I have to square this. So it's going to become x to the 6, y to the 6. Okay? Where are my like bases? X's, what's going to happen to your X's?
0 and 1.
They're going to go to nothing, to 1. I guess I shouldn't say nothing. Goes to 1, so we don't need to write it. 2 squared is 4, and then we're just with y to the 6th power.
That's so dope.
It is pretty dope.
4x to the 3rd.
Yeah, bro.
Yeah, you forgot to square the x to the 3rd, y to the 3rd. All right. What happens if your exponent is a negative with a quotient?
Come on now. You have to switch them so it'll be A on bottom, B on top.
Yeah. Missing an equal sign in there. So if you have a quotient being taken to a negative power, the trick for a negative power is if you take the reciprocal of your quotient, it would then make it become a positive power. Does everybody see why that would be the case? Don't write this in your notes, you can just watch. If I end up with a to the negative n and then b to the negative n, wouldn't I send that down, send that up?
Yeah.
So then the b would end up on the numerator and the a would end up in the denominator. So if we just take the reciprocal right away, it's going to make it become a positive exponent, and then we can just do what we did before, distribute it to the numerator, distribute it to the denominator. Okay? So what's this one going to get us? I'll write this up here. Make it a positive exponent. A to the n. So what's the reciprocal of 3/4? 4/3, which is then going to make my exponent become a positive 3. And then we get 4 to the 3rd, 3 to the 3rd. 4 to the 3rd is what? 1664 over 27.
Yeah.
Okay, next one. 2x squared all over y to the 3rd to the negative 2. What can I do to make it become positive? Flip it. So y to the 3rd goes to the numerator.
No, when
2x squared. Don't change the signs of the exponents on the numerator and the denominator. Don't do that. Just flip it to make that become a positive. So So now we're going to get y to what power? Y to the 6th over 2 squared, just 4. X squared squared is x to the 4th. Okay. Would it be incorrect to distribute right away? No. Then I would get 2 to the negative 2, x to the negative 4, y to the negative 6. Then I would just have to move everything, right? And that would get me there anyways. All right. Let's do a tricky one. I'll write it down. This is the last one for your notes. Let's see if we can do it. I've got 2/3 to the negative 2 power. And I got 6m over 2n to the negative 3 power. So let's do the first quotient first. Reciprocal of 2/3 is 3/2. That's going to make that become a positive 2. The reciprocal of 6m over 2n is 2n over 6m. That's going to make it become a positive 3. All right, distribute. 3 squared is 9. 2 squared is 4 times 2 to the 3rd is 8. N to the 3rd is just going to be n to the 3rd over, oh boy, 6 to the 3rd. 36 times 6. 6, 18, 2, 16.
Sure. What? Oh, 216.
M to the 3rd.
Yeah, I agree.
Okay. Does your N and your M have the same base? Nope, so I'm not going to do anything with those. So now I got to focus just on my numbers. You've got 2 fractions. How do you reduce 9/4 times 8 over 216?
You do 1, 4, and then 2 over 8. I mean 2, like 8.
Yep. Can 216 and 9 reduce? 216 divided by 9 is 24. That's nice. So 9 goes to a 1. 216 goes to a 24.
So it's just
1 times.
So it's just 2.
2 over 24, which reduced to 1 over 12. Good. So what's my final answer going to look like? What's in the numerator?
2 and n3.
Why is there 2?
Wait, what are you talking about?
It'll be
I thought you asked what's in the numerator.
Yes.
3
Just an N3.
over.
If you put the 1 there, it's not really incorrect. 12m to the 3rd.
Oh, you divided it.
Yeah. 2 over 24 would go to 112. Okay? Any questions? So, we added 3 more to our repertoire of exponents.